G'day people, welcome to the old how to figure out what the speed of light is by melting chocolate experiment. Now this is a wave, excuse me, it's a transverse wave obviously, just like any old light wave. And if it finds itself moving in an area where the gap between where it starts and where it ends happens to be an exact number of wavelengths or an exact multiple of half a wavelength long, it'll move this way, reflect off the opposite wall, and it'll create a standing wave doing this something like this. Let me see if I can draw it nicely. That ain't bad, you get the idea. If that happens, there will be some positions here, antinodes, where the wave energy is maximum because it goes from maximum amplitude up to maximum amplitude down, back and forth, back and forth, back and forth. Another one, another one, another one, all of these antinodes. This is positions of greatest energy, greatest disturbance of the medium that the wave is going through. Over here, we've got some nodes. And these are areas where there's barely any movement, barely any energy passing through the material that the wave is actually moving through. Now, in the case of microwave ovens, these standing waves happen all the time. They don't happen everywhere in the oven. The manufacturers try not to make them happen because they bring with them a bit of a problem. They end up cooking the food better in some places, these places, than in other places. Right? Most energy, least energy. But they're hard to avoid. Almost every microwave oven, because of its internal shape and just the distance between one wall and the other wall and the direction that the light is, that the microwaves are moving in, will generate standing waves somewhere. And mine is no exception. Now, to avoid this problem of cooking too much and not enough, you have one of these. Right? It rotates the food and it moves the food through the positions of most energy and least energy, most, least, and it doesn't matter. Right? And so microwaves overall, even if there is an area that does this, tend not to cook food more in one area than they do in another. Now we can use this to actually figure out what the speed of light is. If you don't let the microwave rotate, this will happen. If you take out the mechanism that rotates it and sit it there, put some food in, put something in that will melt, like chocolate, excuse me, and put it in, turn it on for 30 seconds, the microwave oven will melt the chocolate in spots. Wherever there's this standing wave situation going on, it will melt there and there and there, right, all the way along the antinodes. Right? It'll sort of start evenly melting everything everywhere else, but between these antinodes and nodes, and there's almost no energy going into the chocolate there. So if you've got some chocolate straight out of the fridge, that'll stay cold and that'll start melting. Anything around here will just warm up because it's getting a reasonably even heat where there's no standing waves happening. But I'm interested in over here because we can use this to figure out what the wavelength of the light of the microwaves that happen to be used by that microwave oven actually is. And if we know the wavelengths and we know the frequency, which is typically written in the instruction manual that came with the oven, you can use V equals F lambda and find out what the speed of light is. So we're going to do a bit of reverse engineering with a chocolate bar to figure that out.